A new scientific paper has just exposed a chilling discovery about the interstellar visitor 3I-ATLAS. At precisely 2.1 astronomical units from our Sun, 3I-ATLAS started venting hydrogen cyanide, an invisible, deadly gas. Scientists call it outgassing. But here's what they won't tell you. Comets don't hold their breath and then exhale poison at a predetermined distance. Yet Atlas did exactly that. As this happened, NASA's key asteroid hunting probe went dark, with its crucial data from the closest flyby mysteriously missing from the public record. Coincidence? Or cover-up? Tonight, we reveal what the blackout was meant to reveal. Stay with us until the end, because the cover-up ends today. If you're as captivated by these mysteries as I am, hit that like button and subscribe so you don't miss what happens next as this story continues to develop. Leave a comment telling us where you're watching from, what time it is in your corner of the world, and whether you think we're being told the whole truth about these discoveries, or just the version they want us to hear. And if you'd like to help spread the word, share this video on X, Facebook, Reddit, or even your private group chats. You're the force that drives this search for truth. Thank you for standing with us. Part 1. The Poison Switch. Picture this. You're an astronomer scanning the night sky, tracking what you believe is just another chunk of ice and rock from beyond our solar system. Then, one morning, you receive data that stops you cold. The object you've been watching, the one drifting silently through space for years, has suddenly begun venting a molecular cloud of hydrogen cyanide into the void. Not gradually, not predictably, but all at once, like someone flipped a switch. This isn't speculation. This is confirmed science. On September 14th, 2025, the James Clerk Maxwell Telescope detected hydrogen cyanide emission from 3I-ATLAS at a distance of 2.13 astronomical units from our Sun. The detection exceeded 5 sigma confidence, meaning the chances this is a false positive are less than 1 in a million. The production rate measured 4.0 plus or minus 1.7 times 10 to the 25th molecules per second. That's not a typo. We're talking about quadrillions upon quadrillions of cyanide molecules streaming off this object every single second. Now, before you think I'm just here to scare you, let me explain what hydrogen cyanide actually is. You've probably heard of it. It's the compound that gives certain seeds their bitter almond smell, the gas used in some of history's darkest chapters of chemical warfare. In your body, it blocks cellular respiration at the molecular level. You suffocate from the inside out, even while breathing normally. But here's the thing. Hydrogen cyanide is also completely natural in comets. Many comets contain it, locked in their icy hearts, released gradually as they warm approaching the Sun. So detecting it isn't automatically alarming. What's alarming is the when and the how. Look at the timeline. Astronomers observed 3I-ATLAS throughout August 2025 when it was farther from the Sun, colder, supposedly less active. The James Clerk Maxwell Telescope pointed its dish at Atlas multiple times in those weeks. They searched specifically for hydrogen cyanide emission using the exact same frequencies, the same detection methods, and they found nothing. Not a whisper, not a molecule. The spectra came back flat, empty, silent. Then mid-September arrives. Atlas has moved slightly closer, now at 2.1 astronomical units. The telescope looks again, using identical methods, and suddenly the hydrogen cyanide signature blazes into existence. Not a gradual increase, not a slow warming trend, an abrupt activation. Think about what that means. Imagine you're watching a dormant volcano. For months it's cold and quiet. Instruments detect no thermal anomalies, no gas emissions, no seismic activity. Then one day, without any of the usual warning signs of magma movement or crustal stress, it suddenly erupts. You'd wonder what triggered it, wouldn't you? You'd suspect something unusual happened deep underground, some mechanism. You don't understand. That's where we are with Atlas. Typical comets show gradual volatile emissions as solar heating intensifies. Water vapor appears first, then carbon monoxide, then other compounds in a predictable sequence tied to their sublimation temperatures. Atlas skipped that script entirely. It went from completely dormant to actively venting one of the most toxic compounds known to chemistry, and it did so at a distance where most comets are barely waking up. I want you to consider a possibility that sounds insane until you really think about it. What if 3I-ATLAS is not a passive icy body drifting aimlessly through space? What if it's a dormant probe, engineered by something, or someone, designed to activate at a specific distance from our star? What if that hydrogen cyanide emission isn't random sublimation, but a deliberate release, or perhaps even the exhaust signature of internal systems coming online? I know how that sounds. I know the immediate reaction is to dismiss it as conspiracy thinking. But stay with me, because over the next hour, I'm going to walk you through a series of events, anomalies, and cover-ups that, when assembled together, paint a picture far stranger and more disturbing than a simple comet. We're going to examine why NASA's Psyche spacecraft went mysteriously dark during the exact window when it should have captured the best images of Atlas. We're going to look at the vanishing tail mystery, where Atlas displayed an anti-tail pointing toward the Sun, defying basic physics. We're going to dig into why the European Space Agency is sitting on spectral data from their Mars orbiters, releasing only low-resolution images while claiming they need months to analyse what should be straightforward observations. And we're going to compare Atlas side by side with a normal comet, Comet Swan, to show you exactly how bizarre Atlas truly is. By the end, you'll understand why some researchers are quietly asking questions that most scientists won't touch publicly. Questions about artificial objects, about hidden agendas, about whether humanity is being slowly prepared for a revelation we're not ready to accept. But first, we need to understand what happened during the silent week. Because while Atlas was activating its poison cloud, something very strange was happening with our spacecraft. Something that suggests someone doesn't want us looking too closely at this object, and that's where our investigation truly begins. Part 2. The Silent Week. Psyche goes dark. NASA's Psyche spacecraft launched in October 2023 with a primary mission that sounds straightforward enough. Travel to the metal-rich asteroid Psyche, orbiting between Mars and Jupiter, and study its composition to understand planetary cores. It's a mining prospector mission, essentially, equipped with multispectral imagers, a magnetometer, and a gamma-ray spectrometer. But here's what makes Psyche relevant to our story. Its trajectory and its instruments give it the capability to observe other objects in the inner solar system. It's not dedicated to hunting asteroids or comets, but if something interesting crosses its field of view during its cruise phase, Psyche can absolutely capture it. And in early September 2025, something very interesting was about to cross its field of view. 3I-ATLAS reached its closest approach to Psyche's position around September 3rd and 4th. The geometry was nearly optimal. Atlas would be bright enough, close enough, and positioned such that Psyche's images could capture detailed observations, potentially resolving surface features or coma structures that ground-based telescopes couldn't see. This was the window. This was when we should have gotten our clearest views of Atlas from a spacecraft perspective, but we didn't. Instead, we got silence. The Psyche mission maintains a public data archive where processed images are uploaded regularly. Researchers, journalists, and space enthusiasts can browse through observations, tracking the spacecraft's journey and its various engineering tests. If you go through that archive carefully, examining the timestamps on image files, you'll notice something peculiar. There's a gap. From September 1st through September 7th, 2025, the archive shows no images. None. Not a single observation logged. No calibration frames, no engineering test shots, nothing. The spacecraft effectively went dark for a full week, bracketing exactly the period when Atlas was closest. Now, before you jump to conclusions, let me acknowledge the mundane explanations. Spacecraft don't operate continuously. They have scheduled downtime for instrument resets, for software uploads, for telemetry relays when the Deep Space Network antennas are pointed elsewhere. Sometimes spacecraft enter safe mode if a computer hiccup occurs, shutting down non-essential systems until ground controllers diagnose the problem. Sometimes data gets delayed in processing, and images taken during a certain period won't appear in the public archive until weeks later, after calibration and quality checks. These are all normal aspects of space operations, but here's the problem. NASA hasn't explained the gap. There's no official statement saying Psyche underwent a planned instrument reset during this period, or we experienced a telemetry issue and data from early September is still being processed. There's just silence about the silence. I reached out through available channels. I checked mission status updates. I combed through NASA's public communications. Nothing addresses this specific gap. It's as if everyone involved with Psyche decided independently and simultaneously that the first week of September wasn't worth documenting. Or alternatively, that documenting it was too sensitive for public release. Think about what that implies. If the gap is truly accidental, truly just an unfortunate coincidence of routine maintenance overlapping with Atlas's closest approach, you'd expect transparency. You'd expect NASA to say, yes, we were offline then, here's why, unfortunately we missed observing Atlas, but here's what we're doing instead. The absence of any explanation suggests either negligence so profound it borders on incompetence or deliberate suppression of data that revealed something NASA doesn't want public yet. Consider the timing more carefully. Atlas suddenly activates its hydrogen cyanide emissions on September 14th, just 10 days after this mysterious blackout period. During the blackout window, Atlas would have been close enough for detailed spacecraft imaging. After the blackout ends, Atlas is farther away and beginning its chemical transformation. It's almost as if someone wanted to ensure no high-resolution images existed from the critical transition period, the days when Atlas might have been changing, activating, showing external signs of its impending emission burst. If Atlas is indeed artificial, if it has visible structures or ports or mechanisms that would betray its nature, those features might only be apparent during close-up observation with spacecraft-grade instruments. Ground-based telescopes, even the largest ones, see Atlas as little more than a fuzzy dot. Psyche could have changed that. But during the exact window when it could have changed that, Psyche went dark. Let me paint a speculative scenario for you. Suppose Atlas began showing structural anomalies in late August or early September. Suppose Psyche's images captured something, panels opening, gas jets firing from specific points, rather than uniformly across the surface, geometric patterns inconsistent with natural fragmentation. Suppose those images were flagged immediately by automated analysis or by mission scientists who realized they were looking at something extraordinary. What would happen next? Would NASA release those images immediately to the public, or would they be classified, routed through security reviews, shared with defense and intelligence agencies before any public disclosure? I'm not saying this definitely happened. I'm saying the gap in the archive is consistent with it having happened. And the complete silence from NASA about why the gap exists doesn't exactly inspire confidence in the innocent explanation. We're going to see this pattern repeat throughout our investigation. Data gaps, delayed releases, low-resolution images when high-resolution ones should exist, spectral analyses that take months when they should take weeks. It's the architecture of a soft cover-up, not a blatant lie, but a strategic management of information flow, ensuring the public learns only what authorities decide we're ready to learn, on their timeline, in their framing. And while we're kept in the dark, Atlas continues its journey inward. Its hydrogen cyanide cloud expands. And whatever it's doing, whatever it's becoming, we're being prevented from seeing clearly. But Psyche's blackout is only the beginning. Next, we need to talk about Atlas's tail, or rather the mystery of where that tail actually is, and why it sometimes points in directions that violate everything we know about comets. Part 3. The Vanishing Tail Mystery. Comets are supposed to be simple. I mean conceptually simple, even if the physics gets complicated. You have a nucleus, a dirty snowball of ice and rock. As it approaches the sun, solar radiation heats the surface. Ices sublimate, turning directly from solid to gas. This outgassing lifts dust particles off the nucleus, creating a glowing cloud called the coma. Then solar wind, a stream of charged particles blasting out from the sun at 1,000,000 miles per hour, pushes the gas and dust away from the nucleus. Radiation pressure from sunlight also pushes the dust. The result is a tail that always points away from the sun. It doesn't matter which direction the comet is travelling. The tail is defined by the sun's influence, not the comet's motion. This is basic comet physics, understood since the 1600s. So when a comet's tail points toward the sun, you know something strange is happening. The Hubble Space Telescope observed 3I-ATLAS in August 2025, capturing images that should have shown a typical coma and tail structure. Instead, astronomers noticed something bizarre. Atlas displayed what's called an anti-tail, a narrow feature extending toward the sun rather than away from it. Now, anti-tails aren't completely unknown. They can form when we observe a comet from a specific geometric angle, catching a view of dust grains that have drifted into the comet's orbital plane, creating an optical illusion where part of the tail appears to point sunward. It's a projection effect, a trick of perspective. but those anti-tails are usually faint, narrow, and easily explained once you work out the geometry. Atlas's anti-tail didn't fit that profile neatly. It was too prominent, too persistent, and the geometry of Earth's observing position didn't fully account for it. Amateur astronomers tracking Atlas reported even weirder observations. Instead of a smooth, continuous tail, they saw weak intermittent puffs of gas, erratic jet-like features firing from the nucleus, and a coma that brightened and dimmed unpredictably. Some nights Atlas looked active, with a faint tail extending behind it. Other nights, from the same distance to the Sun, it looked almost inert, a bare point of light with minimal coma. This inconsistency is unusual. Once a comet starts actively outgassing, it generally maintains a baseline level of activity that correlates with solar heating. You don't expect it to flicker on and off like a broken light bulb unless something about its nucleus, its rotation, or its internal structure is highly abnormal. Compare this with any normal comet you care to name. Take Comet Swan, officially designated C2025R2, which appeared earlier in 2025. Swan was spectacular. Ground-based telescopes captured it with a massive bright coma and a textbook tail streaming away from the Sun. Amateur astrophotographers posted images showing intricate structures in the coma, shells of gas and dust pulsing outward, as the nucleus rotated and exposed fresh ice to sunlight. Swan behaved exactly as cometary physics predicts. Bright, active, consistent, beautiful. Atlas, by contrast, is dim, erratic, and defies easy categorization. If you put their images side by side, you wouldn't guess they belong to the same class of object. One looks like a comet, the other looks like something pretending to be a comet but not quite getting the performance right. So what explains Atlas's weird tail behavior? Let's consider the conventional explanations first. Fragmentation is one possibility. If Atlas's nucleus is breaking apart, chunks of ice separating from the main body, that could create irregular outgassing as different fragments warm at different rates. Fragmentation events often produce dust clouds and jets that temporarily brighten a comet before it fades again. But fragmentation usually leaves visible evidence: multiple nuclei, expanding debris clouds, dramatic increases in brightness followed by fading. Atlas hasn't shown clear signs of breaking apart. Another explanation involves the comet's rotation. If Atlas spins with active vents concentrated in certain areas of its surface, we'd see brightness variations as those vents rotate into and out of sunlight. This could explain the flickering, but it doesn't easily explain the anti-tail. Rotation-based jets would still be pushed away from the Sun by solar wind and radiation pressure. They might create asymmetric tails, curved tails, even spiral patterns, but not a tail pointing sunward. Charged dust grains interacting with the Sun's magnetic field offer another potential mechanism. If Atlas is producing unusually charged particles, electromagnetic forces might push some material in unexpected directions, temporarily overcoming radiation pressure. This is exotic but not impossible. Comets are electrically active environments. The solar wind is a plasma, ionized particles carrying electric currents. Magnetic fields twist and reconnect. In that chaotic environment, strange things can happen, but again, this explanation requires Atlas to be chemically unusual, producing dust or gas with properties unlike normal comets. Which brings us back to the central question: why is Atlas so different? Here's where we start drifting into speculation, but speculation grounded in the anomalies we're observing. What if Atlas's tail isn't purely natural? What if directed emissions are involved, vents or nozzles releasing gas at specific angles, creating thrust that alters the normal tail configuration? Imagine a spacecraft firing attitude control thrusters. The exhaust doesn't stream away based on solar wind. It goes wherever the thruster is pointed. If Atlas has anything resembling propulsion, even crude gas jets for orientation or trajectory correction, those emissions would create visible plumes that wouldn't follow normal comet physics. They could create the erratic puffs, the intermittent brightening, the anti-tail structures that have astronomers scratching their heads. I'm not saying this is definitely happening. I'm saying it's one hypothesis that fits the observations better than any conventional explanation I've seen proposed. And here's the uncomfortable truth. If Atlas is artificial, if it's maneuvering, if it's actively controlling its gas emissions for reasons we don't understand, then we're not dealing with a passive object that we can safely predict and ignore. We're dealing with something that has agency, something that might be responding to its environment, something that activated its hydrogen cyanide cloud precisely when and where it chose to. That changes everything. That transforms ATLAS from a curiosity into a potential threat. But to understand the full scope of that threat, we need to look at the institutions that should be investigating it and ask why they're stonewalling instead. Which brings us to the European Space Agency and their very peculiar handling of the Mars flyby data. Part 4, ESA's Lockbox, the delayed release game. In early October 2025, 3I-ATLAS executed a close flyby of Mars, passing within about 5 million miles of the Red Planet. This was a golden opportunity for observation. The European Space Agency operates two sophisticated spacecraft in Mars orbit, the ExoMars Trace Gas Orbiter and Mars Express, both equipped with instruments capable of studying atmospheric gases and imaging distant objects. As ATLAS approached, ESA announced they would attempt observations, capturing images and spectra to characterize the comet's composition and activity. This was legitimate science. ATLAS would be closer to these orbiters than to any Earth-based telescope, potentially revealing details impossible to see from our planet. ESA positioned their spacecraft, pointed their instruments, and collected data. Then came the waiting game. On October 7th, 2025, ESA released initial images showing ATLAS as a small dot against the star field, captured by the Trace Gas Orbiter from approximately 30 million kilometers away. The images were celebrated as a technical achievement. Look, we saw the interstellar visitor from Mars orbit, proof that our instruments work, proof that international cooperation in space science delivers results. The press releases were enthusiastic, but they were also strangely vague about details. The images showed ATLAS's position, its motion across the sky, and a faint coma. But they were low resolution, fuzzy, almost cartoonish in their lack of detail. Some commentators joked they looked like Space Invaders graphics, pixelated blobs against black backgrounds. For an agency that routinely produces stunning high-resolution images of Mars's surface, of atmospheric phenomena, of Martian moons, these ATLAS images were oddly primitive. More importantly, ESA announced that spectroscopic data, the measurements of what gases ATLAS is emitting, which molecules are present, what isotopic ratios exist, all the scientifically valuable information that would tell us about ATLAS's origin and nature, that data would require months of analysis before public release. Months, for spectroscopy that, in principle, is straightforward. You point a spectrometer at an object, collect photons, analyze the wavelengths, identify absorption or emission lines corresponding to known molecules. This isn't cutting-edge research requiring years of modelling. It's routine observational astronomy. Even if calibration is needed, even if you're being exceptionally careful, weeks should suffice, not months. So why the delay? Let's consider what that spectroscopic data might reveal. We already know ATLAS is emitting hydrogen cyanide at massive rates. But what else is it emitting? Are there other unusual molecules, compounds that don't fit cometary profiles? Are isotopic ratios anomalous, suggesting material formed under conditions unlike those in our solar system, or unlike those expected in interstellar space? Is there evidence of artificial compounds, molecules that don't occur naturally? These are the questions spectroscopy could answer, and these are the questions ESA apparently doesn't want answered quickly. By delaying release, they control the narrative. They ensure that when data finally becomes public, it's been thoroughly vetted, contextualized, framed in language that minimizes alarm and maximizes scientific caution. Nothing about this proves a cover-up, but everything about it is consistent with institutional gatekeeping. Compare ESA's response to ATLAS with their handling of other recent discoveries. When Mars Express detected methane plumes in the Martian atmosphere, data was released within weeks, sparking vigorous scientific debate about biological versus geological sources. When the Trace Gas Orbiter mapped water vapour in Mars's atmosphere, results were published promptly. Those discoveries were exciting, but they weren't threatening. They didn't challenge fundamental assumptions about what's possible in our solar system. ATLAS does. An active interstellar object emitting toxic gases near Earth orbit is unprecedented. If that object shows signs of artificial origin, if its composition is inexplicable by natural processes, the implications are staggering. And perhaps that's why ESA is moving slowly, drip-feeding information, waiting to see how the public and scientific community react before revealing more. There's also the question of coordination. ESA isn't operating in isolation. They share data with NASA, with other space agencies, with defense and intelligence communities. If ATLAS is truly anomalous, if spacecraft observations revealed something extraordinary, that information wouldn't stay within ESA's science directorate. It would be escalated, classified, discussed at levels far above public-facing researchers. The scientists analysing the data might be told to slow down, to double-check everything, to ensure no premature conclusions leak. Not because they're part of a conspiracy, but because institutions naturally move toward caution when faced with information that could cause panic or geopolitical instability. And make no mistake, confirmation that ATLAS is artificial would be destabilizing. It would raise immediate questions. Who built it? Why is it here? What is it doing? Does it pose a threat? Are there others? Those questions would demand answers from governments, from militaries, from international bodies completely unprepared to address them. So ESA sits on the data. They release pretty pictures that show nothing controversial. They promise detailed analysis is coming. Just be patient. Science takes time. And meanwhile, ATLAS continues inward, getting closer to the Sun, closer to Earth, and nobody with access to the best data is telling us what they actually see. But we're not entirely in the dark. We can compare ATLAS to other objects. We can use the observations we do have to build a case. And one of the most damning pieces of evidence comes from asking a simple question. If ATLAS were truly just a comet, how would its behaviour compare to an actual comet observed during the same period? That comparison is devastating. But before we get there, we need to address an even darker possibility. What if ATLAS's hydrogen cyanide cloud isn't just an emission? What if it's a weapon? Part 5. Weaponized Cyanide Hypothesis. Let's talk about poison clouds in space. It sounds like science fiction, the plot of a B-movie where evil aliens gas the Earth from orbit. But the physics is real, and it's worth understanding before we dismiss the scenario as absurd. ATLAS is currently producing hydrogen cyanide at a rate of approximately 4 times 10 to the 25th molecules per second. That's an incomprehensible number, but let's put it in context. If you collected that output for 1 hour, you'd have enough hydrogen cyanide to fill several Olympic swimming pools in gaseous form. Over days, weeks, months, the cumulative cloud would be enormous. But space is also enormous, and gas expands rapidly in a vacuum. By the time that cloud spreads out, its concentration drops dramatically. The inverse square law is brutal. Double the distance and the concentration falls to 1/4, triple the distance, 1/9. By the time any cloud from ATLAS reached Earth, it would be so diffuse that detecting it would be difficult, let alone experiencing toxic effects. So ATLAS's hydrogen cyanide cloud, by itself, isn't an immediate threat to life on Earth. The atmosphere provides massive protection. Even if a dense plume somehow reached our planet, it would burn up in the upper atmosphere, dissociate into harmless atoms, never reach the surface in dangerous concentrations. You'd need a targeted, sustained release directly into Earth's orbital path, combined with extraordinarily bad luck in atmospheric entry dynamics to create surface-level toxicity. This isn't happening naturally. But, and this is the critical question, could it happen artificially? Could ATLAS, if it's indeed an engineered object, manipulate its trajectory and its emissions to deliver a concentrated poison cloud to a specific target? That's where we enter speculative but not impossible territory. Imagine ATLAS possesses a propulsion system, something subtle, perhaps using outgassing as reaction mass. Small trajectory corrections, undetectable from Earth because we expect cometary orbits to be gravitationally determined, could position ATLAS such that its perihelion, its closest approach to the Sun, places it directly in Earth's orbital path. Then, at the optimal moment, it releases a concentrated burst of hydrogen cyanide, not uniformly in all directions but directionally, through a nozzle or vent aimed at Earth's predicted position. The cloud expands, but it expands along a trajectory calculated to intersect Earth's orbit at the precise moment Earth is passing through that region. Its orbital mechanics meets chemical warfare. Possible? In principle, yes. Practical? That depends on ATLAS's capabilities, which we don't know. Let's consider the engineering requirements. First, propulsion. ATLAS would need a method to change velocity, even slightly. Gas jets could work. Release volatile material asymmetrically, and you generate thrust. This is exactly how some spacecraft perform attitude control using small thrusters that vent gas. If Atlas has internal reservoirs and controllable vents, it could adjust its path. Second, targeting. Atlas would need to know where Earth is, where Earth will be, and calculate intercept trajectories. That requires sensors, computers, ephemerids, not beyond the capability of any spacefaring civilization. Third, timing. The hydrogen cyanide release would need to occur at a precise moment, when Atlas is positioned such that the expanding cloud intersects Earth's orbit at the right time. Again, straightforward orbital mechanics, well within the realm of solvable problems. Now here's a disturbing thought. The sudden activation of hydrogen cyanide emissions at 2.1 astronomical units might not be random. It might be a test, a systems check, confirming that internal mechanisms work, that chemical pathways are functional, that storage containers haven't leaked or degraded during centuries or millennia of interstellar cruise. You power up the probe, verify emissions, monitor how the cloud expands, check whether ground-based observers notice, see how they react. Then you continue inward, gathering data, refining targeting, waiting for the optimal release window closer to perihelion. This is how you'd engineer a reconnaissance and delivery system. You'd build in redundancy, verification stages, fail-safes. The September emission could be exactly that, a pre-deployment test. And if that's true, the implications are chilling. We're not dealing with a passive threat, a dumb object that might coincidentally endanger us. We're dealing with an active threat, something capable of responding to its environment, something following a programmed sequence, something that has objectives we can only guess at. The muffler analogy is worth considering. If Atlas has a large internal engine, something generating power for propulsion or communication, that engine would produce exhaust. Hydrogen cyanide could be a byproduct, a chemical signature of whatever technology is running inside. Just as a car's exhaust reveals the combustion process, Atlas's emissions might reveal internal activity. And if the engine just turned on, if systems just activated, the exhaust would suddenly appear, exactly as we observed. This isn't proof, but it's a framework that explains the observations more coherently than natural comet physics. The worst-case timeline looks like this. Atlas entered our solar system dormant, a sleeper probe conserving energy, minimizing emissions, appearing as nothing more than an inert interstellar rock. As it approached the Sun, internal systems monitored solar radiation, distance, trajectory. At a pre-programmed threshold, approximately 2.1 astronomical units, activation protocols initiated. Systems powered up. Chemical reservoirs opened. Hydrogen cyanide vented, both as a test and as a byproduct of engine ignition. Ground-based observers detected the emission, noted the anomaly, but mainstream science interpreted it as natural cometary behavior. Meanwhile, Atlas continued inward, refining its trajectory, approaching perihelion at approximately 1.36 astronomical units, where solar heating would be intense, where natural cometary activity would peak, providing perfect cover for further emissions. And if Earth happens to be in the wrong place at the wrong time, a concentrated cloud intercepts our orbit, and we face a threat we never saw coming because we dismissed it as just a comet. I want to be clear. This scenario requires assumptions. It requires Atlas to be artificial, to possess capabilities we haven't directly observed, to have intent we can only infer. But every alternative explanation, every attempt to fit Atlas into the box of normal cometary behavior, leaves anomalies unexplained. The sudden emission onset, the anti-tail, the spacecraft blackouts, the data delays. At some point, the accumulation of anomalies demands we consider hypotheses we'd rather avoid. And this hypothesis, the weaponized cyanide scenario, fits the data disturbingly well. But there's a bigger picture here, a web of conspiracy theories and hidden agendas that suggest Atlas might be part of something even stranger. To understand that, we need to talk about Project Blue Beam. Part 6. Blue Beam Trigger Protocol. There exists a conspiracy theory so elaborate, so cinematic, that even hardened skeptics find it fascinating, if not credible. It's called Project Blue Beam, and according to its proponents, it's a secret plan by shadowy global elites to stage a fake alien invasion using advanced holographic technology, satellite-based projection systems, and electromagnetic manipulation. The purpose? to terrify the world's population into accepting a one-world government, surrendering national sovereignty, and embracing authoritarian control in exchange for protection against the fabricated extraterrestrial threat. It's the ultimate false flag, a cosmic Reichstag fire, designed to exploit humanity's deepest fears for political ends. Most researchers dismiss Bluebeam as unfounded paranoia, a mashup of legitimate concerns about government propaganda mixed with science fiction tropes. But within the conspiracy community, Bluebeam is taken seriously, and there's a specific detection protocol that believers watch for. The protocol goes like this. Mainstream science and media have spent decades dismissing UFO sightings, ridiculing eyewitnesses, and maintaining that extraterrestrial visitation is unlikely, bordering on impossible. If that narrative suddenly reverses, if prominent skeptics begin acknowledging the alien presence, if governments start admitting they've been tracking anomalous objects, that flip signals blue beam activation. It means the stage is being set, the public is being primed, the holographic projectors are powering up. When the fake invasion begins, people will believe it because their trusted authorities told them aliens are real. It's predictive programming followed by execution. And once you know to watch for that flip, you can't help noticing when it seems to happen. Over the past few years, we've seen precisely that shift. The US government declassified UFO videos. Pentagon officials testified before Congress about unidentified aerial phenomena. Mainstream media outlets that once mocked UFO enthusiasts now run sober analyses of military encounters with unexplained craft. NASA announced dedicated UAP research programs. The cultural narrative around aliens has shifted from fringe conspiracy to serious inquiry. True believers in Bluebeam see this as confirmation. The trigger is being pulled. And now, conveniently, an interstellar object appears, behaving strangely, emitting toxic gases, defying easy explanation. Is Atlas the test balloon? Is it the opening act? The warm-up event that conditions the public to accept the next phase? Let's explore this hypothesis carefully. Suppose Bluebeam is real, or at least suppose powerful interests want to manipulate public perception regarding extraterrestrial threats. Atlas is perfect. For that purpose, it's real. It's detectable by amateur astronomers and professional observatories alike. You can't easily fake it because too many independent observers are tracking it. But you can control the narrative around it. You can selectively release data, emphasize certain anomalies while downplaying others, and gradually escalate public concern. You start with, it's just a comet. Then, well, it's emitting unusual gases. Then, its behavior doesn't match our models. Then, we're seeing structures that don't appear natural. Each revelation increases anxiety, primes the audience for the next step. Eventually, when you're ready for the full reveal, whether that's a staged holographic invasion or an actual first contact scenario, the public is already halfway there. They've been conditioned to expect something extraordinary. The technology required for Bluebeam is speculative, but not entirely implausible. Satellite-based laser projection could create atmospheric displays visible over large areas, especially at night. Combine that with drones projecting coordinated images, and you could simulate fleets of spacecraft. Add electromagnetic frequency manipulation, targeting the human brain's susceptibility to certain wavelengths, and you could induce mass hallucinations or auditory phenomena. Throw in media control, ensuring news outlets broadcast the approved narrative, and you have a recipe for manufactured reality. Whether this technology exists at the scale Bluebeam requires is debatable, but elements of it certainly exist. The question is whether anyone has the will and resources to deploy it. Here's where Atlas fits disturbingly well. If you want to stage an invasion, starting with a small, distant object makes sense. It's manageable. It doesn't immediately panic the population. It allows authorities to control the pacing. You study how people react to the initial anomaly reports. You gauge which narratives gain traction online. You adjust your strategy based on real-time feedback. Atlas becomes a live test. A psychological operation masters astronomical observation. And because it's real, because telescopes genuinely detect it, skeptics can't dismiss it as pure fabrication. They're forced to engage with the data, to explain the anomalies, to grapple with possibilities they'd rather ignore. Meanwhile, the public watches, absorbs, and slowly shifts from disbelief to cautious acceptance of the idea that something out there is not what we thought. Critics of Bluebeam point out logical flaws. Staging a global deception of that magnitude would require unprecedented coordination between governments, space agencies, militaries, and media organisations across dozens of countries with conflicting interests. Leaks would be inevitable. Whistleblowers would emerge. The operation would collapse under its own complexity, and those are valid objections. But consider an alternative. What if Bluebeam isn't a coordinated conspiracy but an emergent strategy? What if multiple actors, pursuing their own agendas, independently converge on the same tactic, using the alien threat narrative to justify budgets, control populations, or distract from other crises? You don't need a secret cabal if structural incentives push everyone toward the same behaviour. And in that scenario, Atlas doesn't need to be part of a master plan. It just needs to be useful, a convenient crisis that various interests exploit simultaneously. I don't know if Project Bluebeam is real. I don't know if Atlas is part of it. But I know the pattern is visible. I know the narrative is shifting. And I know that when patterns emerge, when the unlikely starts feeling inevitable, it's worth asking who benefits. But let's step back from the conspiracy angle for a moment and consider another pattern. One that's been quietly documented by astronomers for years. One that suggests Atlas might not be unique. One that asks a simple, terrifying question. What if the stars themselves aren't what they seem? Part 7. The Pattern of Vanishing Stars. Beatriz Villarroel is not a household name, but her research might be one of the most unsettling contributions to astronomy in the past decade. Working with historical photographic plates, those glass negatives exposed by telescopes throughout the 20th century, and archived in observatories worldwide, Villarroel began cross-referencing old sky surveys with modern digital observations. Her goal was straightforward: identify objects that appeared in vintage photographs but have since disappeared. She called her project VASCO, the vanishing and appearing sources during a century of observations. What she found should have made headlines. In comparing the USNOB catalogue with modern Pan-STARRS data, she identified roughly 100 sources that appeared as stars or star-like objects in the 1950s, but showed no counterpart in contemporary surveys. They simply vanished. Now, before we leap to aliens, let's examine the conventional explanations. Photographic plates are temperamental. Emulsions degrade. Cosmic ray strikes create false dots. Developer chemicals leave artifacts. Dust specks on the glass mimic stars. Atmospheric distortions during exposure can produce ghost images that weren't really there. All of these are legitimate concerns, and Villarroel's team addressed them systematically. They filtered out obvious artifacts, cross-checked multiple plates from different observatories, and focused on cases where the vanished object appeared consistently across several exposures. The result? A subset of disappearances that couldn't be easily explained by instrumental or chemical errors. These objects appeared real in the 1950s and are genuinely absent today. So what happened to them? Mainstream astronomy offers several natural explanations. Failed supernovae could briefly brighten a star to detectable levels before collapsing, back into obscurity. Lens flares from bright nearby stars might create phantom sources. Extreme stellar variability could make a star visible during one epoch and invisible during another. Photometric calibration errors might misidentify the brightness of background galaxies, making them appear star-like when they're actually too faint for modern surveys to catalogue at that magnitude. These explanations cover many, perhaps most, of the vanishing star candidates. But Villarroel maintains that a small residual remains, cases where none of the standard explanations fit comfortably. And that's where things get interesting. Suppose, for the sake of argument, that some of these vanishing objects weren't stars at all. Suppose they were artificial light sources, beacons or probes positioned in our solar system or nearby interstellar space, operating during the mid-20th century for reasons we don't understand, then powering down or moving on. How would we distinguish them from stars? Photographic plates have limited resolution and sensitivity. A point source is a point source. If a probe wanted to camouflage itself as a star, maintaining a steady luminosity, not moving perceptibly relative to the background over human timescales, it could easily fool observers for decades. Then, when its mission concluded or its power source depleted, it switches off. The star disappears. We're left scratching our heads, inventing astrophysical explanations for something that was never astrophysical to begin with. This connects to ATLAS in a troubling way. If ATLAS is artificial, if it's a probe from some non-human intelligence, it's likely not the first or the only one. Civilizations capable of interstellar travel wouldn't send a single scout. They'd send fleets, networks, redundant systems. Some probes might be passive observers, parking in stable orbits, watching and recording. Others might be active, approaching stars, sampling atmospheres, investigating planets. Over centuries or millennia, their operational status would vary. Some would fail. Some would complete missions and deactivate. Some would relocate. To us, detecting them would be a matter of luck and persistence. We might glimpse one briefly, catalogue it as a comet or asteroid, then lose track as it manoeuvres or powers down. Or we might see it as a faint star-like object, never realising it's artificial until it vanishes. The implications are staggering. If even a fraction of Villarroel's vanishing stars are artificial objects, the solar system and nearby space are far more populated than we've assumed. We're not alone in the cosmic wilderness. We're in a neighbourhood, possibly a busy one, and we've been oblivious because our observational methods can't distinguish between natural and artificial point sources. ATLAS might be part of that hidden population, one probe among many, distinguishable only because it became active at a moment when our detection capabilities had advanced enough to notice the anomalies. And if that's true, then the sudden activation of ATLAS's hydrogen cyanide emissions might not be preparation for an attack on Earth. It might be a signal, a communication burst aimed at other probes, a coordination protocol we've accidentally intercepted. Think about what that means. We're eavesdropping on a conversation we don't understand, involving participants we can't see, using a language we haven't deciphered. ATLAS emits hydrogen cyanide. We interpret it as a poison cloud. But what if it's a message, encoded in molecular emission patterns, readable by sensors on other probes scattered through the system? What if the anti-tail, the erratic jets, the timing of the emissions, all constitute a data packet, a burst transmission saying, "I've arrived, systems operational, proceeding to next waypoint"? We wouldn't recognise it as communication because we're looking for radio signals or laser pulses, not chemical plumes. But an advanced civilization might use chemistry, biology, or physics we haven't mastered. They might embed data in unexpected channels, exploiting aspects of nature we barely understand. The vanishing stars, the sudden appearance of ATLAS, the strange behaviours, all of it suggests a hidden layer of reality operating just beyond our perceptual threshold. And if we're only now beginning to notice, it's because our technology finally caught up to the subtlety of what's out there. But there's another control mechanism at play, one that keeps us from probing too deeply, one that restricts who can reach out into that darkness. And it's encoded in law, enforced by governments, and rarely questioned by the public. Let's talk about who's allowed to talk to the stars. Part 8. Radio Silence Regulation. You can listen to space all you want. Build a radio telescope in your backyard, aim it at the sky, tune across frequencies and record whatever signals you detect. That's legal. Governments encourage amateur radio astronomy. Universities provide open access data from professional observatories. The universe is broadcasting constantly, pulsars ticking like cosmic metronomes, quasars blazing across light years, the cosmic microwave background humming at 3 Kelvin. You can listen to all of it. But if you want to transmit, if you want to send a message outward, that's a different story. Suddenly you're navigating a maze of regulations, license requirements, and unwritten rules that effectively restrict deep space transmission to government-authorized entities. Why? If space is empty, if nobody's listening, why does it matter who transmits? The International Telecommunication Union governs global radio spectrum allocation. They assign frequency bands for terrestrial communication, satellite operations, navigation systems, and radio astronomy. Some bands are protected, reserved for passive listening to ensure natural signals aren't drowned out by human noise. Transmitting in those bands is prohibited. Fair enough. We don't want interference compromising scientific observations, but the restrictions go further. High-power transmissions, especially those aimed beyond Earth, often require special permits. National regulations vary, but in many countries, broadcasting towards space falls under telecommunications law, military communications law, or both. The explicit justification is spectrum management and preventing interference. The implicit justification is control. Consider the logic. If authorities genuinely believed extraterrestrial intelligence doesn't exist or isn't listening, there'd be no reason to restrict transmission. You can yell into the void all you want without harming anyone. But if they suspect otherwise, if there's even a small probability that someone out there is monitoring, then unregulated transmission becomes a risk. What if an amateur astronomer, using a homemade transmitter, sends a message that provokes a response? What if that response is hostile or misconstrued as hostile, triggering an interstellar incident governments aren't prepared to handle? Better to keep transmission authority centralized, ensuring any contact is managed by official channels with military and diplomatic oversight. That's the pragmatic explanation. The paranoid explanation is darker. Governments want exclusive communication rights because they've already established contact, or they expect to, and they don't want civilians muddying the waters. There's historical precedent for radio silence protocols. During World War II, ships maintained radio silence in contested waters to avoid revealing their positions to enemy submarines. The same logic applies in space. If hostile probes are out there, listening, analysing, triangulating sources of intelligent transmission, then every broadcast we send is a beacon, a targeting marker. Silence is survival. But we haven't been silent. Humanity has been broadcasting inadvertently for over a century. Radio, television, radar, all leaking into space, announcing our presence. Any nearby intelligence with sensitive receivers knows we're here, so the argument for enforced silence collapses unless it's not about hiding our existence, but about controlling the content of intentional messages. Let's speculate. Suppose governments detected anomalous signals decades ago, subtle patterns in radio noise that suggested artificial origin. Suppose they responded quietly, tentatively, establishing a back-channel dialogue with whatever's out there. Suppose that dialogue is ongoing, mediated by classified agencies, conducted on frequencies the public can't access. In that scenario, civilian deep space transmission becomes a threat because it could disrupt delicate negotiations or reveal information the public isn't supposed to know. The regulations aren't about spectrum management, they're about secrecy. And if ATLAS is part of that hidden ecosystem, a probe sent by whoever we've been talking to, then its sudden activation might correlate with a message we sent or received, a diplomatic exchange that escalated from communication to action. I spoke with an amateur radio operator who expressed frustration about these restrictions. He built a capable antenna array, capable of detecting weak signals from deep space. He wanted to conduct his own SETI experiments, listening for patterns, and if he found something interesting, he wanted to respond. But when he researched the legal requirements for transmitting beyond Earth, he encountered barriers. Licensing agencies asked for detailed technical specifications, demanded justifications for the transmission, and ultimately discouraged him from proceeding. The message was clear. Listening is fine, talking is not. He interpreted this as evidence that authorities don't want the public engaging independently with potential extraterrestrial intelligence. And maybe he's right. Maybe the silence protocols aren't about protecting us from aliens. Maybe they're about protecting the secret from us. Now connect this to ATLAS. If civilian transmission is restricted, if only authorized entities can broadcast to space, then any signals ATLAS receives, any communication protocols it's following, originate from government sources. We're not just passive observers of ATLAS's behavior. We might be participants unknowingly in an interaction orchestrated by agencies that answer to no public oversight. And if that interaction goes wrong, if ATLAS interprets a signal as hostile or receives instructions we don't understand, we'll experience the consequences without ever knowing what provoked them. The radio silence regulation ensures we remain ignorant, and ignorance, when dealing with existential threats, is the most dangerous position of all. But ignorance might be temporary. ATLAS is approaching perihelion, its closest point to the Sun, and that's when things could escalate beyond anyone's control. Part 9. Solar sabotage at perihelion. Perihelion is the moment of maximum solar influence. For ATLAS, current orbital predictions place its closest approach at approximately 1.36 astronomical units from the Sun, expected to occur in late November 2025. 1.36 AU is about 127 million miles, still safely outside Earth's orbit but well within the zone where solar radiation intensifies dramatically. For a normal comet, perihelion triggers peak activity. Surface ices sublimate rapidly. Dust production spikes. The coma expands to maximum brightness. Tails extend millions of miles. It's the comet's moment of glory, a brief fireworks display before it swings back into the cold outer solar system. But if ATLAS isn't a normal comet, if it's an artificial object with engineered systems. Perihelion could be something else entirely. It could be the activation window, the moment when internal mechanisms powered by solar energy reach operational capacity. The sun isn't just a light bulb, it's a fusion reactor broadcasting across the electromagnetic spectrum, from radio waves to gamma rays. It pumps out a solar wind, a supersonic stream of protons and electrons travelling at 1,000,000 miles per hour. It generates magnetic fields that twist and snap, launching coronal mass ejections, massive clouds of plasma that can disrupt satellites and power grids when they hit Earth. And critically, it provides power. Solar panels work by converting photons into electricity. Any spacecraft operating in the inner solar system uses solar power. It's abundant, reliable, and requires no fuel. If Atlas has solar panels, or some equivalent energy collection system, its power output increases quadratically as it approaches the Sun. At 1.36 AU, solar irradiance is roughly half what it is at Earth's distance, still plenty to charge batteries, activate dormant systems, and execute pre-programmed operations. Imagine Atlas was designed to hibernate during its interstellar cruise, conserving energy, minimizing emissions, drifting inert for centuries. As it entered our solar system, passive sensors monitored increasing solar radiation. At a predetermined threshold, 2.1 AU, preliminary systems activated, venting hydrogen cyanide as a test or byproduct. Now, approaching perihelion, primary systems prepare to engage. Whatever Atlas was sent here to do, it does it when solar power peaks. That could be launching secondary probes, transmitting data back to its origin, adjusting its trajectory for a planetary encounter, or deploying something we haven't anticipated. And all of this would happen during the same period when a natural comet is most active, providing perfect camouflage. Observers would expect Atlas to brighten, to emit more gas, to behave erratically. Any anomalies get attributed to cometary physics rather than artificial intervention. There's another factor at play. Solar activity itself is variable. The Sun operates on an 11-year cycle, alternating between solar maximum when sunspots, flares and CMEs are frequent, and solar minimum when activity quiets. We're currently approaching the next solar maximum, expected around 2025 to 2026. This means Atlas's perihelion coincides with heightened solar activity, increased likelihood of flares and CMEs. If Atlas is engineered to harness or react to solar phenomena, this timing is optimal. A well-timed CME could deliver a surge of charged particles, energizing systems, triggering protocols, or even masking Atlas's own emissions within the natural storm. Ground-based observers would struggle to distinguish artificial signals from solar noise. It's the perfect cover. Let's consider a worst-case scenario. Atlas reaches perihelion in late November. A moderate-sized CME launches from the Sun, travelling outward. Atlas's trajectory places it directly in the CME's path. The plasma cloud engulfs the probe, delivering an electromagnetic pulse and a flood of high-energy particles. Atlas's systems, designed to activate under these conditions, respond. Vents open, stored volatiles release directionally, generating thrust. The probe adjusts its trajectory, now aimed at a calculated intercept with Earth's orbit. Simultaneously, additional gas emissions, including concentrated hydrogen cyanide, jet outward along vectors designed to intersect Earth's position weeks or months later. From our perspective, we see a comet brightening naturally at perihelion, perhaps fragmenting slightly, exhibiting strong cometary activity. We don't realize the comet is maneuvering, targeting, weaponizing its emissions until it's too late. Is this plausible? Physically, yes. Orbital mechanics allows trajectory adjustments via directed thrust. Chemistry provides the propellant. Solar power provides the energy. The only question is whether Atlas possesses the engineering, and we can't answer that question because the data is hidden, delayed, or dismissed. NASA's Psyche went dark during the optimal observation window. ESA is sitting on spectroscopic results. Hubble images show anomalies explained away as projection effects. The architecture of this potential disaster is already in place. The only uncertainty is intent. If Atlas is a probe, does it intend harm, or is it merely indifferent, executing protocols that coincidentally threaten us? Either way, perihelion is the inflection point. After late November, Atlas's trajectory is set. If something is going to happen, it starts then. And we'll be watching, helpless, hoping the anomalies resolve into something benign, but preparing for the possibility they don't. But how do we even recognize the threat? How do we distinguish a comet from a weapon? The answer is comparison, and that's exactly what we're about to do. Part 10. Control Case. Swan vs. Atlas, the smoking gun. Science progresses through comparison. You don't prove something is unusual by studying it in isolation. You prove it by contrasting it with the normal case, showing that the differences exceed expected variation. That's why control groups exist in experiments. That's why astronomers catalogue thousands of objects, building statistical baselines for what typical looks like. And when something deviates significantly from the baseline, you investigate. Comet C 2025 R2, designated Comet Swan, provides the perfect control case for ATLAS. Both are comets, both were active during 2025, both observed by similar instruments. But their behaviours couldn't be more different. Comet Swan appeared in the inner solar system in early 2025, discovered by the Solar and Heliospheric Observatory's wide-field imagers. It was a Kreutz sun grazer, a fragment from a larger comet that broke apart centuries ago, now on a trajectory that would bring it within a few million miles of the Sun's surface. Astronomers predicted spectacular activity as Swan approached perihelion in March 2025, and they weren't disappointed. Swan developed a massive coma, a glowing cloud of gas and dust visible even to backyard telescopes. Its tail extended millions of miles, a brilliant streamer of ionized gas pushed by solar wind, photographed by amateur astronomers worldwide. The European Space Agency's SOHO spacecraft captured Swan's final plunge toward the Sun, watching as it brightened dramatically, vaporized partially, and either fragmented or survived as a much smaller remnant. Swan was everything a comet should be: bright, active, predictable, beautiful. Now look at ATLAS. Discovered in 2024, ATLAS followed a different trajectory, entering the solar system from interstellar space, not from the Oort cloud like Swan. Its orbit was hyperbolic, unbound, meaning after perihelion it would leave the solar system forever unless something changed its velocity. That alone makes ATLAS interesting, but not unprecedented. We've seen other interstellar visitors, Oumuamua in 2017, Borisov in 2019. What makes ATLAS unusual is its activity profile. Throughout most of its approach, ATLAS remained faint, barely detectable, showing minimal cometary features. No bright coma, no obvious tail, just a dim point of light that brightened sluggishly as it approached the Sun. Then in mid-September 2025, at 2.1 AU, hydrogen cyanide emissions suddenly spiked. Not water vapour, not carbon monoxide, which are more common cometary volatiles. Hydrogen cyanide, a less abundant, more volatile compound, appearing abruptly. Compare the images. Swan's coma is radiant, symmetrical, expanding uniformly as gas and dust lift off the nucleus. ATLAS's coma is faint, asymmetric, showing jet-like features suggesting localized emission rather than uniform sublimation. Swan's tail is textbook perfect, streaming away from the Sun in a graceful arc, shaped by radiation pressure and solar wind. ATLAS's tail is erratic, sometimes present, sometimes absent, occasionally pointing toward the Sun in defiance of basic physics. If you showed these images to a planetary scientist without context, they'd identify Swan as a comet instantly. ATLAS would prompt questions. What is this object? Why does it behave this way? Is there something wrong with the data? The brightness comparison is equally stark. Swan reached naked eye visibility, magnitude 3 or 4 at peak, easily seen from dark sites. ATLAS remains faint, magnitude 10 to 12, requiring decent amateur telescopes to detect. This matters because brightness correlates with activity. A bright comet is actively sublimating, releasing massive amounts of gas and dust. A faint comet is relatively dormant. Yet ATLAS is releasing hydrogen cyanide at prodigious rates, 4 times 10 to the 25th molecules per second. Where's the dust? Where's the reflected sunlight that should make it brighter? Either ATLAS's nucleus is unusually dark, absorbing rather than reflecting light, or its emissions are predominantly gaseous, lacking the dust component that makes comets glow. Both possibilities are unusual. Here's the rhetorical punch. If ATLAS and Swan were both natural comets, products of the same physical processes, they should exhibit similar behaviours scaled to their sizes and compositions. But they don't. SWAN behaves exactly as centuries of cometary science predict. ATLAS behaves like an outlier, an anomaly, an object following different rules. You could argue ATLAS is just a weird comet, that natural variation is large, that we don't fully understand cometary physics. And you'd have a point, but when you add the hydrogen cyanide spike, the anti-tail, the spacecraft blackouts, the data delays, the sudden activation at a specific distance, the accumulation of anomalies tips the scales. At some point, invoking natural variation becomes less parsimonious than considering alternative explanations. And the alternative, that ATLAS is artificial, engineered, following a programmed sequence, explains the data more elegantly. We'll revisit this comparison as ATLAS approaches perihelion in late November. If ATLAS suddenly brightens, develops a massive coma and tail, behaves like SWAN did, then maybe the anomalies were just early-stage weirdness that resolved into normal cometary activity. But if ATLAS continues its erratic behaviour, if the hydrogen cyanide emissions intensify without corresponding brightness increases, if the tail remains anomalous, if new unexplained features appear, then the case for artificiality strengthens. This isn't the end of the investigation, it's the midpoint. We're watching in real time as the data accumulates, as ATLAS reveals itself, as the answer becomes unavoidable. And while we watch ATLAS, other developments in science and technology are quietly reshaping what we think is possible. The world of 2025 is stranger than it was even 5 years ago. Let's zoom out and see what else is happening, because context matters. The universe doesn't operate in isolation, and neither does ATLAS. Part 11. AI predicts the collapse of fusion startups. In October 2025, a research team at MIT released a sobering analysis using machine learning models to predict the viability of private fusion energy companies. Fusion, the process that powers stars, has been humanity's dream for nearly a century. Achieve controlled fusion on Earth, and you unlock effectively limitless clean energy. Deuterium fuel is extractable from seawater. Helium byproducts are non-radioactive. No carbon emissions, no meltdown risks, just abundant power. For decades, fusion remained perpetually 30 years away, a running joke in physics departments. But in the 2020s, private companies joined the pursuit. Commonwealth Fusion Systems, TAE Technologies, Helion Energy, dozens of startups backed by billionaires and venture capital, all promising commercial fusion by the 2030s. The MIT study poured cold water on that optimism. Using financial modelling, technical assessments, and historical data on energy technology deployment, the AI predicted that approximately 70% of these companies would fail by 2030, unable to overcome engineering challenges or secure sufficient funding. Why does this matter for ATLAS? Because energy is power, literally and politically. Control over energy resources determines which nations dominate, which economies thrive, which populations live comfortably versus desperately. If fusion succeeds, it decentralizes energy. Any country with technical expertise can build reactors, ending dependence on fossil fuels, on uranium, on geopolitical choke points. But if fusion fails, if the startups collapse, if the dream dies again, then existing power structures persist. Oil-producing nations remain influential. Nuclear power with its waste and proliferation concerns stays relevant. Renewable energy with its intermittency challenges continues requiring massive grid infrastructure. The status quo endures. And in that context, an external threat like ATLAS becomes useful. Imagine a scenario where governments need to justify enormous expenditures, need to consolidate control, need to rally populations around a common enemy. An alien probe, a cosmic threat, a weapon drifting toward Earth, that's the perfect crisis. Consider the timing. Fusion companies are struggling in 2025. The AI models predict most will fail by 2030. ATLAS appears in 2024, activates in 2025, approaches perihelion in late 2025. If ATLAS escalates, if it becomes a publicized threat, governments could declare a planetary emergency. Resources get redirected. Civilian fusion projects get nationalized or defunded. Military priorities dominate. Space defense becomes the justification for budgets that dwarf anything seen before. And conveniently, the private fusion sector, which might have democratized energy, collapses under lack of investment. I'm not claiming this is a coordinated plan, but systems don't need conspiracies to produce conspiratorial outcomes. Incentives align. Crises get exploited. The AI's prediction of fusion startup failure might be accurate on its own terms, but it also describes a window of vulnerability, a period when humanity's energy future is uncertain, when fear could drive policy more than optimism. Let's add another layer. If Atlas is artificial, if it was sent by an advanced civilization, what would they know about us? If they've been observing Earth for decades or centuries, they'd understand our energy dilemmas. They'd see our reliance on combustion, our slow progress toward fusion, our geopolitical fragmentation. An intelligence looking to destabilize or manipulate humanity might time their intervention for maximum impact, arriving when we're least prepared, when our technological optimism is crumbling, when internal divisions are sharpest. Atlas's arrival in the mid-2020s, during this fusion uncertainty, during rising global tensions, during increasing climate and economic pressures, is either extraordinary coincidence or calculated timing. And I'm not inclined to believe in coincidences anymore. This isn't just about Atlas. It's about recognizing that existential threats don't occur in a vacuum. They intersect with existing crises, amplify them, exploit vulnerabilities. Whether Atlas is a probe, a weapon, or a natural object we've misunderstood, its impact on human civilization will depend on context, and that context in 2025 includes an energy sector on the brink, geopolitical instability, and a population increasingly distrustful of institutions. Atlas could be the spark in a very dry forest. But energy isn't the only frontier where things are getting strange. Let's shift our gaze outward, to the dark spaces between stars, where invisible monsters drift silently, waiting to be discovered. Part 12. The Milky Way's Rogue Black Hole. Update. Black holes are the universe's ultimate predators, gravity so intense that not even light escapes. Space-time warped into a one-way trap where the normal rules of causality break down at the event horizon. Most black holes we know about are either stellar mass remnants, 10 to 100 times the Sun's mass, formed when massive stars collapse in spectacular supernova, or supermassive monsters, millions to billions of solar masses, lurking at galactic centers like cosmic engines of destruction. Both types are detectable because they interact violently with their surroundings. Stellar mass black holes often exist in binary systems, pulling gas off companion stars through tidal forces, heating that gas to millions of degrees through friction and compression, making it glow brilliantly in X-rays. Supermassive black holes power quasars, devouring entire solar systems worth of material in their accretion disks, broadcasting across the electromagnetic spectrum with luminosities that outshine entire galaxies. But what about isolated black holes? Black holes drifting alone through interstellar space, not feeding, not glowing, invisible except for their gravitational influence. How many of those exist? We don't know. We fundamentally can't see them directly. They emit nothing, reflect nothing, appear as absolute voids against the cosmic background. We only detect them when they pass in front of a background star, briefly magnifying its light through gravitational microlensing, a phenomenon Einstein predicted where massive objects bend space-time itself, creating a natural lens that focuses and brightens the light from more distant sources. The effect is subtle, temporary, and requires extraordinary luck to observe. In September 2025, a team analysing data from the Hubble Space Telescope and ground-based surveys announced the detection of a rogue black hole approximately 12 solar masses, drifting through the Milky Way roughly 4,000 light-years from Earth. The detection came from a microlensing event lasting several months, where a distant star's light brightened and dimmed in a pattern consistent with a massive dark object passing between us and the star. By analysing the light curve, the precise pattern of brightening and dimming over time, the duration of the event and the magnitude of brightening, astronomers calculated the lens's mass and velocity, 12 solar masses, moving at roughly 100,000 miles per hour relative to the local stellar population. This is a rogue, a black hole ejected from its birth site, possibly during an asymmetric supernova that gave it a gravitational kick, now wandering the galaxy, invisible, detectable only by chance geometric alignment. The mathematical analysis required to identify this object was formidable. The researchers had to distinguish the black hole's signature from countless other variables: stellar variability, instrumental noise, atmospheric distortion. They cross-referenced observations from multiple telescopes, verified the event through independent datasets, and modelled different scenarios to eliminate alternatives. A planet wouldn't produce the right light curve, a dim star would show different chromatic effects, only a black hole fit the observations. The achievement represents years of painstaking work, automated surveys monitoring millions of stars simultaneously, waiting for the telltale signature of gravitational lensing to appear. The discovery raises an uncomfortable question. If we found one rogue black hole through microlensing, how many more exist undetected? Microlensing requires precise alignment. The black hole, the background star, and Earth must line up within a tiny angular tolerance, typically less than a millionth second, smaller than resolving a dime from 1,000 miles away. The odds of any given star being lensed at any given moment are minuscule, so detecting even one rogue implies a much larger population. Some estimates suggest tens of millions of stellar mass black holes drift through the Milky Way, most concentrated in the galactic disk where star formation is highest, some in the halo, all invisible unless they happen to lens a star or encounter matter to accrete. We're swimming in a sea of invisible gravitational traps, and we only notice when we accidentally stumble into one's detection cone. Consider the implications. Our galaxy is roughly 100,000 light-years across, containing hundreds of billions of stars. If tens of millions of black holes are scattered through that volume, the average distance between them might be a few dozen light-years. Close enough that stellar mass black holes constitute a significant hazard for any interstellar journey. A spacecraft travelling between stars would need to map these invisible obstacles, detect them somehow, navigate around them. And if we're only just beginning to find them through microlensing, how would an interstellar civilization handle this problem? They'd need detection methods far beyond our current capabilities, perhaps gravitational wave sensors sensitive enough to detect the space-time curvature of isolated black holes, or exotic physics we haven't discovered yet. Connect this to ATLAS, we assume we know what's in our solar system. We've catalogued asteroids, comets, Kuiper belt objects through decades of systematic surveys. We track near-Earth objects that might pose collision risks, maintaining databases of potentially hazardous asteroids. We think we have a reasonable census, but if the Milky Way is full of invisible black holes that we're only now beginning to detect, what else might we be missing? Dark, non-emitting objects that don't fit our detection paradigms, probes that minimize electromagnetic signatures, artificial structures that blend with natural debris. The rogue black hole discovery reminds us that absence of evidence isn't evidence of absence. Just because we haven't seen something doesn't mean it's not there. It might just be invisible to our current methods, sitting in observational blind spots we haven't even recognized exist. Now, I'm not suggesting ATLAS is a black hole. It's clearly emitting light, gas, detectable by telescopes operating across multiple wavelengths. But the principle applies. ATLAS appeared suddenly in our detection systems, classified initially as a comet because that's what our survey telescopes are optimized to find. If it had remained dormant, if it hadn't activated its hydrogen cyanide emissions when it did, it might have passed through the inner solar system unnoticed, just another faint asteroid on a hyperbolic trajectory, too small and dark to trigger our automated detection algorithms. The fact that we're tracking it now is almost accidental, contingent on it becoming active at a time and place where our instruments could detect the activity. How many other ATLAS-like objects have transited the inner solar system undetected over human history? How many are out there now, dormant, waiting, invisible, until they choose to reveal themselves or until we develop detection methods sensitive enough to find them? The rogue black hole also illustrates cosmic indifference. That 12 solar mass black hole doesn't care about Earth. It's not targeting us. It's just drifting, obeying orbital mechanics, a consequence of astrophysical processes billions of years old. If its trajectory happened to intersect Earth's orbit at the same moment we occupy that point in space, we'd be doomed not through malice, not through deliberate targeting, but through sheer bad luck, a random cosmic alignment. ATLAS might be the same. It might not be a weapon aimed at humanity specifically. It might be a probe following a pre-programmed route, executing survey. Protocols designed millennia ago, and we just happen to be in its path. Intent doesn't matter if the outcome is catastrophic. A bullet doesn't need to hate you to kill you. Understanding that the universe doesn't revolve around humanity, that objects and entities pursue their own agendas indifferent to our survival, is both humbling and terrifying. It forces us to confront our cosmic insignificance. We're not the center of creation, not the pinnacle of cosmic evolution, just one species on one planet, potentially in the path of forces and entities we barely understand. This realization should inform how we think about Atlas, about extraterrestrial contact, about our place in the cosmos. And it's a theme that echoes through other recent discoveries, particularly in physics, where we're finding that reality itself might operate on principles we barely comprehend, where quantum mechanics and relativity hint at deeper structures we're only beginning to glimpse. Part 13, Quantum Time Crystals Achieve First Practical Demo. Quantum mechanics is weird. That's not hyperbole. It's descriptive accuracy. Particles exist in superposition, occupying multiple states simultaneously until observed. Entangled particles correlate across distances instantaneously, defying classical intuitions about locality. Uncertainty principles limit what we can know with precision, and now, in 2025, physicists have demonstrated stable time crystals, a phase of matter so strange that even quantum theorists struggled to believe they could exist. A time crystal is a system that exhibits periodic behavior in time, not just in space. Normal crystals, like salt or diamond, have atoms arranged in repeating spatial patterns. Shake one, and it returns to equilibrium. A time crystal oscillates perpetually, cycling through states without external energy input, never settling into equilibrium. It's motion without energy cost, a kind of temporal order that seems to violate thermodynamics, but doesn't, technically, because time crystals exist in non-equilibrium systems, carefully engineered to exploit quantum effects. The concept sounds impossible at first encounter. After all, perpetual motion machines have been dismissed as fantasy for centuries, prohibited by the laws of thermodynamics. Energy cannot be created from nothing. Entropy always increases in closed systems. Yet time crystals thread a needle through these restrictions by existing in open quantum systems where energy flow maintains them in a special state. Not equilibrium, but a stable oscillation that persists indefinitely. Think of it like a quantum version of a planet orbiting a star. The motion continues without additional energy input once established, but it's not creating energy from nothing. The system was set up with initial conditions that permit this perpetual cycling. In March 2025, a team at Google's Quantum AI lab announced they'd created a time crystal in their Sycamore quantum processor, maintaining coherence for over 100 oscillation cycles, orders of magnitude longer than previous attempts. The achievement required exquisite control over quantum states, manipulating individual qubits with laser pulses timed to femtosecond precision. The researchers demonstrated that the system oscillated at half the driving frequency, a hallmark signature of time crystalline behavior, and crucially that this oscillation persisted even when they introduced perturbations designed to disrupt it. The time crystal proved robust, self-correcting, maintaining its temporal pattern through conditions that would destroy conventional quantum states. In August 2025, researchers at MIT demonstrated a room-temperature time crystal using a lattice of nitrogen vacancy centers in diamond, a system that could potentially be scaled for practical applications. This breakthrough eliminated the need for near-absolute zero temperatures and exotic superconducting hardware, bringing time crystals out of specialized laboratory conditions into environments where real-world applications become feasible. The diamond lattice approach uses defects in the crystal structure, places where nitrogen atoms replace carbon atoms, creating quantum systems that remain coherent at room temperature. These nitrogen vacancy centers can be manipulated with microwaves and lasers, driven into time crystalline states that oscillate with remarkable stability. These aren't just curiosities for physics journals. Time crystals could revolutionize quantum computing, providing stable qubits that resist decoherence, the main challenge preventing quantum computers from scaling to useful sizes. They could enable ultra-precise sensors, clocks that never drift beyond quantum limits, memory storage that never degrades because the information is encoded in temporal patterns rather than spatial states. And speculatively, they might underpin technologies we haven't imagined yet, exploiting time's structure in ways classical physics prohibits. Some theoretical work suggests time crystals could be used for quantum communication protocols, for detecting gravitational waves with unprecedented sensitivity, or even for probing the fundamental nature of time itself. Why does this matter for Atlas? Because if human scientists in 2025 are demonstrating time crystals, What might an advanced extraterrestrial civilization have achieved centuries or millennia ago? If Atlas is artificial, its internal systems might utilize physics beyond our current mastery. Time crystalline cores could provide stable energy storage, coherent quantum states for computation or communication, or mechanisms for manipulating space-time in subtle ways. We wouldn't recognize these technologies by looking at Atlas externally. We'd need to dismantle it, analyze its materials at atomic resolution, understand its operating principles through direct examination. But from a distance, all we'd see are anomalies, behaviors, that don't fit natural models, emissions that don't correlate with expected thermal or chemical processes, trajectories that suggest precision beyond natural gravitational dynamics. Consider the hydrogen cyanide emission. We interpret it as sublimation, ice heating and vaporizing as Atlas approaches the Sun. But what if it's a byproduct of a time crystalline energy system? What if Atlas uses a quantum process that generates waste products, and hydrogen cyanide happens to be one of them? The emission pattern, sudden onset, sustained production, would reflect the system's activation, not solar heating. This explains why the emission didn't correlate predictably with distance from the Sun, why it appeared abruptly rather than gradually building as thermal models would predict. It wasn't thermally driven, it was technologically driven, and if time crystal technology is involved, the system could operate with extraordinary efficiency, minimal energy loss, sustained operation over timescales that make conventional power sources look primitive by comparison. The energy budget alone is telling. Chemical reactions store energy in molecular bonds, released through combustion or electrochemistry. Nuclear reactions tap binding energies in atomic nuclei. Both processes are one way. Once the fuel is consumed, it's gone. Time crystals, by contrast, maintain their oscillation indefinitely once established, requiring only minimal energy input to maintain coherence against environmental noise. For a probe travelling between stars, this could mean the difference between decades of operational lifetime and millions of years. A time crystalline power system wouldn't provide thrust, you still need propellant for that, but it could power computers, sensors, communication systems, and control mechanisms essentially forever. Atlas could have launched when humans were still living in caves and still be fully operational today. I want to emphasize, this is speculation. We don't have evidence that Atlas contains time crystals or any exotic quantum technology. But the demonstration of time crystals in 2025 expands the boundary of plausibility. It forces us to reconsider what's technologically feasible. 5 years ago, time crystals were theoretical curiosities, mathematical constructs that physicists debated might violate fundamental laws. Today, they're laboratory demonstrations with practical applications on the horizon. Extrapolate that progress across centuries, across a civilization with resources and knowledge beyond ours, and the gap between our technology and theirs becomes vast. Atlas could be to our spacecraft what our smartphones are to stone tools. We can recognize it's doing something, we can measure some outputs, but understanding how it works, grasping the underlying principles, might be beyond our current conceptual framework entirely. There's another implication worth considering. Time crystals challenge our understanding of entropy, of time's arrow, of how systems evolve toward disorder. They suggest that under certain conditions, perpetual motion-like behaviors are possible within quantum mechanics constraints. If a civilization mastered this, they could build machines that operate indefinitely without refueling, probes that cruise through interstellar space for millions of years, maintaining functionality, waiting for activation triggers. Atlas's apparent dormancy during its journey, followed by sudden activation, fits that profile perfectly. A time crystalline power core could maintain minimal systems indefinitely, just enough processing power to monitor sensors, check position, calculate trajectory, then ramp up to full operation when sensors detect appropriate conditions like proximity to a star or specific electromagnetic signatures, indicating a technological civilization. We're looking at Atlas through the lens of conventional physics, conventional engineering assumptions built on our limited experience with space exploration. But it might be operating on principles we're only now beginning to glimpse in our most advanced laboratories. The fact that we're discovering these principles at all suggests they're not impossibly exotic, just advanced. They represent a higher rung on the technological ladder, one that any sufficiently persistent scientific civilization would eventually reach. And if we're already catching up to some of these principles, what else might be within reach? What other technologies are we developing that might have extraterrestrial counterparts? What capabilities might we achieve in the next century that would seem like magic to us today? Turns out we're working on stealth systems that sound suspiciously relevant. Part 14. China's Hypersonic Plasma Shield Patent. In early October 2025, defense analysts discovered a patent filing from a Chinese Aerospace Research Institute describing a plasma-based shielding system for hypersonic vehicles. The patent details weren't classified, oddly enough, suggesting either a deliberate disclosure meant to intimidate rivals, or perhaps an administrative oversight that lets sensitive information slip into the public domain. The system works like this. As a hypersonic vehicle travels through the atmosphere at Mach 5 or faster, aerodynamic friction heats the air to plasma temperatures thousands of degrees, creating a glowing sheath around the vehicle. This plasma naturally interferes with radar, making the vehicle harder to track, but it also creates communication blackouts, prevents thermal imaging, and causes structural heating problems that engineers have struggled with for decades. The Chinese patent describes using electromagnetic fields to shape and stabilize this plasma sheath, turning a problem into an advantage. Magnetic coils generate fields that push the plasma into specific configurations, creating zones of dense ionization that actively deflect incoming electromagnetic radiation, essentially a force field against radar and directed energy weapons. The technical specifications suggest a multi-layered approach, with different field geometries optimized for different threat profiles. Against radar, the plasma creates a diffuse, constantly shifting surface that scatters incoming waves unpredictably. Against laser weapons, the ionized particles absorb and disperse the coherent light before it can concentrate enough energy to damage the vehicle's hull. It's elegant physics weaponized for defense. The patent goes further, suggesting that the system could work in space, not just in atmosphere. Deploy similar magnetic field generators on a spacecraft, seed the surrounding space with ionizable gas, perhaps xenon or argon released from onboard reservoirs, and you create an artificial plasma bubble. This bubble would scatter radar, absorb laser strikes by ionizing before the beam reaches the hull, and potentially interfere with particle beams or electromagnetic pulses. It's not quite the starship shields from science fiction. You're not stopping physical projectiles, but for electronic warfare and directed energy threats, it's remarkably effective. And the patent indicates the technology is mature enough for testing, possibly already flying on experimental platforms. The implications for space combat, satellite protection, and even asteroid or comet interception missions are profound. But there's another implication nobody in the defense community wants to say aloud. If China is developing plasma shields for spacecraft, what's already out there might have them too. Imagine Atlas surrounded by a thin shell of ionized gas, maintained by internal magnetic field generators. This plasma layer would make Atlas harder to characterize spectroscopically from a distance. Light passing through plasma gets scattered, absorbed, and re-emitted at different wavelengths. Spectral lines blur. Emission features get masked. What we interpret as faint, inconsistent cometary activity might actually be sophisticated stealth, a plasma shield modulating how much electromagnetic radiation escapes, making Atlas appear dimmer and more erratic than it actually is. The hydrogen cyanide we detected might be the small fraction that leaks through the shield, while the bulk of emissions are trapped, ionized, and managed by the shielding system. This would explain why Atlas appears fainter than its gas production rates suggest. It's not that Atlas is unusually dark, it's that we're seeing it through a veil, a deliberately engineered obscuration layer that controls what information reaches our telescopes. The Chinese patent also mentions using plasma shields to protect against hypervelocity impacts, small particles travelling at orbital speeds. In space, even tiny debris can punch through metal at those velocities. A plasma shield wouldn't vaporize the debris, but it could ionize surface layers, slightly deflecting the particle or reducing its effective mass by ablating its outer shell. For a probe like Atlas travelling through interstellar space for centuries or millennia, micrometeorite impacts are a real hazard. Over thousands of years, countless collisions would sandblast even the most durable materials, degrading solar panels, pitting optical sensors, and potentially compromising structural integrity. A plasma shield would be excellent armour, keeping the probe intact through countless collisions. And if Atlas has such shielding, it might activate that shield more intensely as it approaches the Sun, protecting against increased solar wind flux and radiation. We'd see this as increased plasma emission, which we'd interpret as cometary activity, never suspecting it's actually defensive technology ramping up in response to environmental threats. The system would be autonomous, responding to sensor data about particle density and radiation levels, adjusting shield strength accordingly. Now let's get conspiratorial for a moment. The timing of this Chinese patent, October 2025, is curious. ATLAS activated its hydrogen cyanide emissions in September 2025. Within weeks, China publicly files a patent for plasma shielding technology that happens to explain some of ATLAS's anomalies. Coincidence? Maybe. Or maybe someone in Chinese aerospace tracking ATLAS through military telescopes with better resolution than civilian instruments observed features that suggested plasma shielding. Maybe they reverse-engineered the concept, or maybe they'd been working on it independently and realized ATLAS validates their approach. Either way, the patent filing says to other nations, we know what's out there, we understand the technology, and we're building countermeasures. It's a geopolitical signal wrapped in technical documentation, and it suggests that classified observations of ATLAS might be far more detailed than anything the public has seen. Consider what military-grade space surveillance systems can detect. Civilian telescopes track brightness, trajectory, and spectral signatures. Military systems add infrared monitoring, electromagnetic signature analysis, even gravitational microlensing effects. If ATLAS is generating magnetic fields strong enough to contain plasma, those fields would be detectable by sensitive magnetometers. If it's releasing ionizable gas, spectroscopic analysis might reveal isotopic ratios inconsistent with natural cometary processes. Military analysts might have detected these anomalies months ago, compiled them into classified reports, and started working on countermeasures without ever informing the public. The Chinese patent might be part of that silent technological race, a move to establish priority and signal capability. There's a darker scenario. What if plasma shield technology isn't just defensive? What if it's offensive? A sufficiently powerful plasma bubble, energized by electromagnetic fields, could act as a directed energy weapon. Shape the fields to focus the plasma into a beam, and you have a superheated jet capable of cutting through materials, disrupting electronics, or even affecting biological tissue. If ATLAS has such a system, the hydrogen cyanide cloud might be a secondary threat. The primary threat could be electromagnetic, a plasma weapon that activates at perihelion when solar power peaks, targeting Earth or our satellites with an energy burst we're completely unprepared to defend against. Our current detection methods wouldn't see this coming. We're watching for kinetic impacts, for gravitational perturbations, for obvious weapons. We're not monitoring for subtle electromagnetic buildups, for magnetic field anomalies around ATLAS, because we think it's a comet, and comets don't carry weapons, except this one might. The physics would work like this. At perihelion, solar flux provides maximum energy for power generation. ATLAS could charge capacitor banks, energize its magnetic field generators to maximum output, and release a large quantity of ionizable gas. The magnetic fields would compress and accelerate the plasma, creating a focused beam with temperatures exceeding those at the sun's surface. Directed at Earth, such a weapon wouldn't need to penetrate atmosphere. It could target satellites, communication networks, GPS infrastructure. A single burst could disable hundreds of satellites, crippling modern civilization's dependence on space-based technology. And because the plasma would dissipate quickly after discharge, forensic analysis would be difficult. We might never prove it was deliberate rather than some natural phenomenon. The development of plasma shield technology, both in China and presumably in the United States and other nations who aren't publicizing their work, tells us something important. We're entering an era where space is militarized, where stealth and electronic warfare extend beyond Earth's atmosphere, where the distinction between civilian and military space assets blurs. And in that context, an object like ATLAS becomes a test case. How do we defend against something we don't fully understand? How do we verify its nature without provoking it, if it's capable of being provoked? How do we coordinate international responses when nations are competing for a technological advantage? These aren't academic questions. They're operational dilemmas that space agencies and militaries are grappling with right now, behind closed doors, in classified briefings. And while they deliberate, ATLAS continues inward, closer to perihelion, closer to whatever it's programmed to do. But here's the thing about secrets, about classified observations and hidden data. Eventually they become impossible to hide, because technology itself is evolving to see what humans cannot, and that's where our story takes perhaps its strangest turn yet. Part 15. The AI astronomer that never sleeps. In the Chilean Atacama Desert, at an altitude of 2,600 meters where the air is thin and the skies are among the clearest on Earth, a new kind of observatory became fully operational in July 2025. It doesn't have a name designed to inspire awe, no Hubble or James Webb grandeur. It's called the Autonomous Transient Detection Array, ATLAS for short, and it represents a fundamental shift in how we observe the universe. ATLAS consists of 40 small telescopes, each with a 40-centimetre aperture, arranged in a grid covering several acres. Individually, none of these telescopes would impress a professional astronomer, but collectively, networked through fibre optic cables to a central AI processing cluster, they form something unprecedented, an observatory that operates entirely without human intervention, 24 hours a day, every single night, automatically selecting targets, capturing images, analysing data in real time, and flagging anomalies for follow-up observation. The AI system running ATLAS was trained on decades of astronomical data, learning to recognise stars, galaxies, supernovae, variable stars, asteroids, everything normal. Its job is to spot abnormal, transient events that don't fit known categories. A star that suddenly brightens or dims, an object moving in an unexpected trajectory, a spectral signature that doesn't match any catalogued source. When ATLAS detects something anomalous, it doesn't wait for a human astronomer to review the data days later. It immediately redirects multiple telescopes to that target, capturing follow-up observations across different wavelengths, building a time series dataset within minutes. If the anomaly persists, ATLAS escalates, sending alerts to other observatories, requesting additional observations, compiling a comprehensive report. The entire process, from initial detection to coordinated follow-up, happens faster than any human-operated system could manage. The AI never gets tired, never gets distracted, never has to wait for committee approval to change observing schedules. Within its first 3 months of operation, ATLAS detected 17 transient events that hadn't been caught by other surveys. Most turned out to be known, phenomena observed from unusual angles or at unexpected times, but 3 remained unclassified, objects or events that existing astronomical models couldn't adequately explain. One was a rapid brightening in a previously catalogued star, intensity increasing by a factor of 50 over just 6 hours, then fading back to baseline over 2 days. No known stellar variability mechanism produces that light curve. It wasn't a supernova, no spectral lines indicating element fusion. It wasn't an eclipsing binary. The timing and symmetry were wrong. It just brightened and dimmed, and then returned to normal, and nobody knows why. The AI flagged it as anomalous, archived the data, and continues monitoring that star, waiting to see if it happens again. The second unclassified event was an object moving through the asteroid belt with an erratic trajectory, small velocity changes that couldn't be explained by gravitational interactions with known bodies. The AI tracked it for several nights, calculated that its path was non-Keplerian, meaning it wasn't following a simple orbit determined by the Sun's gravity alone. Something was perturbing it. Either an undiscovered asteroid happened to pass nearby at exactly the right time, astronomically unlikely, or the object was manoeuvring. ATLAS flagged it for human review, but by the time astronomers examined the data and requested follow-up, the object had moved into a region of the sky obscured by the Milky Way's galactic plane, lost in the background star clutter. It hasn't been reacquired. The third event is still under investigation, a spectral line detected in a distant galaxy that doesn't correspond to any known element or molecule. It could be an instrumental artifact, a glitch in the spectrograph. But the line appeared consistently across multiple exposures, captured by different telescopes in the array, making an artifact less likely. If it's real, it's either a new quantum transition nobody has observed before, or it's emission from something that doesn't exist in our current periodic table. Now think about what ADA represents. It's a machine intelligence scanning the sky, filtering out the ordinary, highlighting the extraordinary, operating continuously without the biases, assumptions, or limitations of human astronomers. And here's the unsettling part. What if objects like ATLAS, what if probes from non-human intelligences, What if their signals and behaviours were designed to be detected by machines, not by humans? What if the entire communication strategy of an advanced civilization assumes that any other technological species would eventually develop AI observers, and that those AI systems would recognise patterns that organic minds miss? We humans look for what we understand: stars, planets, comets, galaxies. Our pattern recognition is tuned by evolution and culture. But an AI trained purely on data, with no preconceptions about what should or shouldn't exist, might see things we're blind to. ATLAS' detection of the non-Keplerian asteroid is particularly relevant to ATLAS. Suppose other ATLAS-like objects are out there, smaller, fainter, manoeuvring subtly. Human astronomers wouldn't prioritise them because they'd assume any trajectory deviations are due to outgassing, the Joukowsky effect, or observational errors. But an AI specifically trained to flag non-Keplerian motion would catch them immediately. ATDA might already be detecting a population of artificial objects in the solar system, flagging them as anomalies, but those flags are sitting in databases waiting for human review, and humans are slow, with a bottleneck. The AI sees, reports, and then waits while we debate, form committees, apply for grants, write proposals. Meanwhile, the objects continue their operations, unimpeded by our sluggish response. There's a philosophical question here that's deeply uncomfortable. What if the universe has been communicating with us for decades, centuries, sending signals, deploying probes, leaving evidence, but we couldn't perceive it because we were looking with human eyes and human assumptions, and now, finally, we've built artificial eyes, AI systems that see differently, that recognise patterns we can't, and those systems are starting to notice what's been there all along. ATDA is just the beginning. Other AI-driven observatories are under construction or planned. Machine learning algorithms are being integrated into existing telescopes, into space-based observatories, into radio telescope arrays. Within a decade, most astronomical observations will be AI-mediated, with humans serving as supervisors and interpreters rather than primary observers. And in that transition, we might discover that the cosmos is far stranger, far more populated than we ever imagined, not because the universe changed, but because we finally learned to see it properly. ATLAS fits into this narrative uncomfortably well. Its anomalies, the sudden hydrogen cyanide activation, the anti-tail, the erratic brightness, these are exactly the kinds of features an AI observer would flag. The human astronomer might dismiss them as cometary quirks, but an AI trained to recognise deviations from natural behaviour would rank ATLAS as highly anomalous, demanding intensive follow-up. And if ATA had been operational when ATLAS was farther out, dormant and faint, would the AI have detected it earlier? Would it have flagged ATLAS as suspicious before the activation, based on subtle trajectory deviations or spectral features invisible to human analysis? We'll never know, because ATDA came online after ATLAS was already famous. But future ATLAS-like objects won't be so lucky. The AI will be watching, learning, refining its detection algorithms based on what it's learned from this case. And that means the era of hidden probes, of objects slipping through the solar system unnoticed, is ending. We're entering an era of machine-mediated transparency, where artificial observers see everything, categorize everything, and leave nothing unexplained for long. But transparency cuts both ways. If AI observatories detect artificial objects, who controls that information? ATDA is funded by a consortium of universities and government agencies. Its data is technically public, but there are procedures for withholding discoveries pending peer review, national security consultations, or international coordination. If ATDA detects something genuinely alarming, something that confirms ATLAS is artificial or reveals additional probes, does that data get released immediately to the public? Or does it get classified, routed through intelligence agencies, and released only after authorities decide the population is ready? The AI doesn't make that decision. Humans do, and humans, as we've seen with Psyche's blackout and ESA's data delays, have a tendency to control information when they're afraid of how people will react. So here we are, in October 2025, watching ATLAS approach perihelion, knowing that AI systems are scanning the skies with capabilities beyond human perception, knowing that governments and space agencies are sitting on data they haven't shared, knowing that fusion startups are failing while black holes drift unseen through the galaxy, and quantum time crystals are becoming reality in laboratories. The context isn't just astronomical anymore, it's technological, political, existential. ATLAS is the focal point, the object that concentrates all these threads into a single narrative, and that narrative is accelerating toward a conclusion we can't yet see but can feel approaching like a distant storm. The question isn't whether ATLAS is artificial. The question is, what happens when we can no longer deny it? What happens when the AI observers accumulate enough data, when the anomalies pile up so high that even the most skeptical scientist has to admit something is profoundly wrong with the natural explanation? What happens when ATLAS reaches perihelion in late November, when solar power peaks, when whatever it's designed to do becomes unavoidable? Do we have a plan? Do governments have protocols for this scenario? Or are we improvising, hoping for the best, treating an existential threat like a bureaucratic inconvenience that can be managed with committee meetings and press releases? I don't have answers to these questions. Nobody does. We're in uncharted territory, navigating by instinct and incomplete data, watching an object that might be the most important discovery in human history, or might just be a weird comet that coincidentally exhibits every anomaly we'd expect from an artificial probe. The ambiguity is torture, the uncertainty is deliberate, and the silence from authorities, the lack of transparency, the careful management of information flow, suggests they're as confused and frightened as we are, but they're committed to the performance of control, to maintaining the illusion that they understand what's happening and have everything under control. But here's what I know for certain. The universe doesn't care about our illusions. ATLAS is real, its trajectory is calculable, its emissions are measurable, its behavior is observable, and whatever it is, whatever it's doing, we're going to find out soon. Perihelion is weeks away. The hydrogen cyanide cloud continues expanding. The AI observatories continue watching. And somewhere, in classified briefing rooms and emergency planning sessions, people with access to data we'll never see are making decisions that will affect all of us. Decisions about how to respond, whether to warn the public, whether to take action or wait and hope. We pulled back the cover on ATLAS. We exposed the anomalies, connected the dots, asked the questions that needed asking, but the cosmos doesn't come with a reset button. You don't get to unsee what's been revealed. You don't get to pretend everything is normal once you've glimpsed the pattern. So watch the skies, not just with your eyes, but with the awareness that what you're seeing might not be what's actually there. Watch for the moments when official narratives shift, when skeptics suddenly become believers, when data that should be public gets classified without explanation. Watch for the signs that something is happening behind the scenes, preparations being made for scenarios they won't discuss publicly. Watch ATLAS as it moves inward, brightens or doesn't, behaves predictably or doesn't, becomes the comet we hoped it was, or reveals itself as something we feared. And remember that the universe is vast, ancient, and full of things we don't understand. ATLAS might be just the beginning, the first object we noticed, because our technology finally advanced enough to detect the anomalies. How many others are out there, dormant, waiting, watching? How long have they been here? And what happens when they all wake up? These are the questions that keep me awake at night, staring at the ceiling, wondering if tomorrow is the day everything changes. The evidence is here, the timeline is clear, the threat is real, and the silence from those who know the most is the loudest warning of all.